Hello, everyone, and welcome to today's Greenbuild webinar sponsored by Kytera. My name is Sherida Sessa, and I'll be your host for today's session titled Indoor Air Quality in the Built Environment, IAQ Strategies for Healthy Buildings. First, I'll cover a few quick housekeeping items. If you experience any difficulties with audio or advancing slides, refresh your screen with F5. If you experience other issues, hit the question mark button to receive immediate assistance. At any time during the presentation, you can submit questions into the Q&A window on the left-hand side of your screen. We will take Q&A at the end of the session, time permitting. And then within 24 hours, you'll receive a link to watch the recording of the session. Feel free to share that with peers or colleagues. And now, I'd like to introduce today's speaker, Liam Bates, CEO of Kytera. Liam, thank you for being with us. The floor is yours.
Perfect, thank you. Excited to be here and excited to talk to everybody about indoor air quality. This is a big passion of mine and something that I love talking about. So happy to have this opportunity, and hopefully we'll have some interesting questions at the end. So today's topic is all around indoor air quality and specifically IAQ as it relates to healthy buildings. So a quick overview, we've got about 40 minutes of presentation in which I will do my best to tell you everything that I know about IAQ. You can see a breakdown of the agenda here, sort of starting with the fundamentals, moving to monitoring and the collection of air quality data, looking at the ROI of having clean air, creating a positive indoor environment. Then we'll look at some case studies, best practices, and we've got about probably around 15 to 20 minutes of Q&A at the end. So if you do have any questions, just put them in the Q&A box and we'll get to those at the end. So just a very brief self-introduction. My name is Liam. I'm the co-founder and CEO at Kytera. I am originally from Switzerland, spent several years in Canada, in Vancouver. And I'll start off with a brief story, which starts in 2014 when I was living in Beijing in China. Beijing, as you may know, is not exactly famous for having the most pristine air in the world. And in 2014, it was really bad. It was sort of peak smog levels, peak pollution, and air quality was a topic that was on everyone's mind. I was out looking for an air purifier, trying to make sure that even if I couldn't control the outdoors, at least I could control sort of my home and make sure that I had a clean indoor space. And I talked to a lot of friends. I went to the homes of friends and colleagues, and many of them had air purifiers. And I asked them, how do these work? Is this working? Is your space clean? Do you feel safe? And I always got the same response, which was, maybe, sort of, I'm not entirely sure. And that's kind of the problem here, is that there are various solutions that can be used in your home. And of course, the same thing applies to really any indoor space, commercial, residential, or anywhere else, which is there are solutions, portable air purifiers, air filters, HEPA filters in your HVAC. And you can assume that they're doing something, but it's really, really hard for us to know. And it's very hard to know with certainty and be able to say, for a fact, this is the air quality in my home, and thus I feel confident about it. And so that really sparked, that was kind of the spark that started this journey to dive into the world of air quality monitoring. It's brought us here, starting a company around air quality monitoring and trying to answer that question of being able to say very, very clearly in a data-driven manner, this is what the air quality is. Because once we can measure air quality, we can start to understand what some of the problems are and what we can actually do to fix it. And throughout this journey, I found all sorts of things in my home at the time that were not necessarily ideal, in ways that improvements and changes could be made that would ultimately make the space a lot healthier. And so that is really what we're doing today at Kytera is providing hardware, software, analytics solutions to help companies be able to measure what's going on with the environment in their spaces so that they can have indoor spaces that are healthier, more energy efficient. So really low carbon, healthy buildings. That's our goal here. So a quick question just to sort of align everybody. There's a poll here. How familiar are you with indoor air quality? So if you can just hit one of the buttons, and in a few seconds we'll take a look. And this is just to really help me calibrate which areas of the presentation to spend a little bit more time on than others. So I'll just give this a few seconds. If you know absolutely nothing about air quality, that's great. We'll be going over everything. But if you are sort of on the other end of the spectrum and you're an expert, you've got a PhD in air quality, definitely be sure to let me know so that I can spend a bit more time on areas that might be relevant. So it looks like we've got about, oh yeah, good number of people have submitted. Give this 5 more seconds and then we will take a look. All right, looks like the vast majority have come in. Okay, perfect. It looks like just about 60% of people are familiar with the fundamentals of IAQ. We've got a few experts in the room, and just about everybody has some sort of baseline knowledge of IAQ. So this is perfect. Well, we'll start off with the fundamentals. Won't spend too much time on this. And we'll look at sort of the basics of IAQ and healthy buildings in general. So really over the past few years, we've seen a massive shift, a lot more emphasis being placed on health and wellness, and indoor air quality is really at the center of this. There are some numbers that are going to come up a lot here, which is the amount of time that we spend indoors, which is, as many of you will know, typically over 90%. We certainly spend more than 90% of our time breathing. So sort of when we put those two data points together, clearly air quality and what we're breathing is really fundamental to our health and well-being. At the same time, there are some major sort of shifts that have taken place. Over the past few decades, there's been an increase in environmental awareness, increased emphasis on sustainability, often a shift towards buildings being more tightly sealed, potentially being ventilated at a lower rate. And there's also been that has led to really an increase often in indoor air pollutants. At the same time, there's also been a shift in what we see outdoors due to climate change. So anybody on the West Coast will be unfortunately very familiar with all of the challenges with wildfires. Australia has had similar challenges with bushfires over the past few years, and really all different corners of the world. Back home in Switzerland this year, we had a major sandstorm with dust coming in from the Sahara and landing all over the Alps. So there are a lot of challenges indoors and outdoors, and these add together to really make health and wellness a really, really important topic. And as a result of this is one of my favorite quotes from Dr. Joseph Allen, who many of you may be familiar with, really popularized the term healthy buildings over the past few years. Workplaces need fresh air, not foosball tables and coffee bars. We've all sort of come to see things such as having a barista on hand, having a slide from the 3rd floor to take you down to the 1st floor and land in a pile of beanbag chairs as standard in many companies and sort of representative of the 21st century workplace. But really where our efforts should be going is around making sure that our workplaces provide fresh air and an environment that helps our people be more efficient, be happier, and be healthier. Again, we're spending the vast majority of our time indoors. Even before the pandemic, this was a growing trend, and I think we've seen that this is massively accelerated, certainly over the past few years, and really been helped along by by COVID. So what is a healthy building? Won't spend too much time on this, but in a nutshell, a healthy building is a commercial, residential, or public building which is designed in ways to promote the health, safety, and well-being of its inhabitants. So this is achieved by combining principles and insights from engineering, construction, medicine, psychology, all these different fields, bring them together and working to create a better environment for the people inside it. And there's been a big shift towards this, and you could also almost say it's been more of a shift away from unhealthy buildings and towards something healthier. And the cost of an unhealthy building is extremely high, and I think those costs have become clearer and clearer over the past few years. Those are driven by the costs of absenteeism, the cost of low employee morale and retention for living or working in an unhealthy building. And from more of a real estate investment perspective, it's the significant increases on the rate of return for healthy real estate. We'll talk about this in a lot more detail in sort of the ROI section in a little bit. I've got a lot of numbers to share with people. So when we think of a healthy building, there are sort of several fundamental principles. There are 9 that are often cited, so the 9 foundations of a healthy building. And you can see a number here. The one that we think is particularly important, so there are a number in here which are tied to air quality. Obviously, the air quality being one of them, but also ventilation, thermal health, dust and pests. These are in many ways, moisture, these are in many ways all tied to ventilation and indoor air quality. But looking at this list, we think IAQ is usually the best place to start. And there are a few reasons for that. Number one is it has a larger impact on employee satisfaction than other factors. So a few studies to share. And we'll be able to share sort of data points and sources with people if interested later. So there's a study conducted in the Netherlands in which 70% of a company's workforce was relocated to a different building, which had better perceived environmental conditions. And the improvement in air quality in this study had the largest effect on reducing employee dissatisfaction. Indoor air quality is also an important factor in getting people back into the office. So in a recent survey, 82% of millennial workers reported they would feel safer returning to the office if they would receive timely and transparent IAQ data. So being able to see that this is being measured and it's being communicated in a transparent and real-time way. And finally, the cost savings of IAQ are substantial. There's, of course, increases in productivity that are associated with this, which we'll talk about. But there's also decreases in cost related to operating ventilation equipment in a more effective and a more intelligent manner. Again, something we'll talk more about in a moment. So we have a lot of people that are familiar with the foundations of IAQ on the call today. Just looking at some of the main parameters that we typically are looking at, and these often come up sort of as the main parameters in various building certifications, be it LEED or RESET or WELL, FitWell, etc. So without going into too much detail, these are sort of usually the top contenders. So PM 2.5 or particulate matter, fine particles. This is really referring to extremely small particles with narrow dynamic diameter smaller than 2.5 microns. So really, really minuscule particles in the air. And these can have a short-term health impact. So you can feel like it's hard to breathe, shortness of breath, can lead to direct decreases in productivity. There's several studies that have shown strong correlations and direct decrease in output and productivity, cognitive function with increases in particulate levels. But there are also serious long-term health implications. So this is definitely one to be aware of. TVOC, volatile organic compounds. This is really a classifier for many, many different types of chemical compounds that can have also short and long-term health impacts. Impacts, again, on comfort, productivity, and just overall health. And sources are often, there's sort of two main categories. One is simply people, too many people in a small space, just like CO2, a lot of breathing and not enough ventilation. But what we often think of sort of more as the main source of TVOCs are materials used in the construction or renovation process, carpets, paint, glue, furniture, all of these things. I'm happy, to talk about any of these in more detail in the Q&A if there's something that anyone's particularly curious or concerned about. CO2 is something that everyone will probably be very familiar with. We're responsible for a lot of CO2 generation as we exhale every minute. And of course, the impacts of CO2 are well known. We feel uncomfortable, we feel drowsy, our productivity, our performance decreases rapidly with increases in CO2 levels. We've all had that feeling of being trapped in a conference room with too many people, not enough fresh air. That's usually a result of high levels of CO2 and high levels of VOCs that make us feel incredibly uncomfortable. The moment you open the windows, you open the door, you go for a walk, you suddenly feel refreshed. Ozone is sometimes a concern, not always. We often think of this as more of an outdoor pollutant, but it can be of concern indoors as well. And temperature and humidity I think are self-explanatory. Having the wrong or levels or poor levels of sort of temperature and humidity management can have a really significant impact on how we feel. When you're in an office that is too hot, you just don't want to do anything. You feel incredibly uncomfortable. And of course, suboptimal levels of temperature and humidity also can lead to or can increase the risk of the spread of viruses, of disease, can lead to mold growth and several other factors. So those are sort of some of the main parameters that are usually of concern. Let's talk about collecting and actually monitoring indoor air quality. So what did the world used to look like? Well, all right, first of all, why should we be measuring this? Well, I kind of touched upon this at the very beginning. When you can see what is going on, your eyes are suddenly opened and you can make sure that your goals are being achieved. You can also understand potentially why they are not being achieved, where the problems are, and ultimately, the goal of having data is to be able to make measurable decisions in a fast and repeatable way. So what did we used to do, and what do we still do in a lot of situations, is spot checks. And so having somebody come around maybe once a year, maybe twice, maybe once a quarter, and taking readings in maybe one, maybe multiple locations throughout a building for a variety of parameters and issuing a report. This is obviously better than nothing, but there are a lot of limitations, and you can kind of see them outlined here. So one of the fundamental ones is that this is a one point in time measurement, but time doesn't stop. Time keeps on moving, and unfortunately, these parameters can be very, very different at different points in time. If we just take, putting aside the complexities of CO2 and particulate matter and VOCs for a moment, if we just think about temperature, taking a temperature reading at 7 a.m. in the morning and at 3 p.m. when the sun is shining through the window in the conference room, this is a fundamental difference. And one reading is definitely not going to be able to give us a holistic picture of what is going on within the space. That's why we have temperature sensors. That's why we have thermostats. Similarly, a reading taken in the dead middle of winter and in the middle of summer also are not going to be representative of all seasons of the year. So this is a fundamental challenge of having limited data. Location is a similar problem. When you're taking a reading if we look at temperature on the south side of a building versus the north, you're going to get fundamentally different readings. And the same thing applies to, for example, PM2 reading, 2.5 readings. If you're close to a kitchen where there's actually a source of particulates being generated, then that's going to look very different to the front door or to a closed conference room. Same thing with VOCs or CO2 levels, which are highly dependent on how is the space being used at the specific particular point in time. And certainly when we're taking a CO2 reading, if it's in a conference room which is maybe not being used as much as it typically is, when that reading is being taken, that's definitely a serious issue. So there's also an issue there with the results essentially being completely gameable, depending on how conference rooms are booked during the point in time where your tests are being run. You're going to end up with very different results. And finally, this one's very easy to overlook, but is potentially one of the most important ones, which is that you are also simply ending up with usually a report which has several data points. It is a snapshot of a point in time. It's not necessarily analyzed to understand what is the pattern, what are the trends throughout the space. And so it's very hard to take action based upon these data points. You will walk away usually knowing I have a problem or I don't have a problem, not this is what some of the issues are and this is what I could do to change them. So with all of these restrictions, it sounds like spot checks aren't really an optimal way to measure indoor air quality. So of course that begs the question, well, why do we do this? Why have we been doing this? Well, the reality was that for a very long time, these were the only options that we had. Indoor air quality monitors were typically lab grade, scientific grade equipment, extremely expensive, extremely cumbersome to operate, large, and that has significantly shifted over the past 10 years. That is no longer the case. And we can look in a moment sort of at what the more modern solution looks like. This is just a quick image to kind of show some of the perils of taking measurements at a single point in time, where you can see over a building's life cycle from the construction phase to flushing it out to really bringing people in and occupying the space and using it, there can be massive changes in air quality. And it's not uncommon to finish the space, flush it out, before everybody moves in, take an air quality reading and say, okay, perfect, we're in the green. And then everyone comes in, and unfortunately, we're right back in the red. But if that reading has been taken in the middle, when the space is maybe being used with higher ventilation than is typically actually going to be the case, or when the rooms are not being used in the true manner in which they ultimately will be, then you're going to end up with a very different reading. And this is a serious risk, because you don't want to end up with the false sense that the space is performing in one way when actually it's performing in a very, very different way. So what's the alternative? Well, there have been major shifts really over the past 10 years or so with technology. Technology that previously cost $20,000 is now in the several $100 range, with no major changes in accuracy for some pollutants, some parameters. Obviously, some parameters, there are still major differences, or they're still too challenging to measure. There are, for example, specific VOCs. I'm definitely happy to dive into this and talk a whole lot more, either in the Q&A or later, sort of one-on-one, if people want to reach out. But really, we've been able to take technology that existed, make it smaller, make it more affordable, make it fit discreetly on a wall, and be able to provide 24/7 monitoring in multiple locations throughout a building. And this is really where the world is shifting, and where the future is at when it comes to measurement. This allows you to have real-time monitoring so that you can know to the minute what is going on within a space at any given time, at any given location throughout a building. You can understand what are the relationships between different parameters. If there are issues that come up, you can respond in real time rather than waiting potentially months or a year before somebody comes in and tells you that something is not working as it should be. And there are many, many examples around pieces of HVAC equipment failing, for example. And again, with temperature, we find out right away, right? If the chiller stops working, you find out pretty quickly that your building is not performing as it should be, or you get complaints very, very quickly, and you can fix it. But the risks with many of those other parameters is that you don't know, because as humans, we are not as sensitive to PM 2.5 as we are to temperature. I can tell you right now if the temperature is wrong, but I cannot necessarily tell you what the level of PM 2.5 is. Unfortunately, my productivity will decrease as a result of this, and I will have some of those longer-term health impacts. So it's something that we want to be able to address in real time. You'll also have a more comprehensive representation of your indoor space. Spot tests are typically maybe one room over here, one room over there, very, very limited in scale. But with continuous monitoring, you can theoretically have this in every room, in every corner of an indoor space. And with more modern reporting and the ability to analyze these monitors against each other, that's when you can start to identify what some of the problems are and actually start fixing them. Because ultimately, that's the goal here, right? It's not just to collect data, it's to be able to create a more positive indoor environment that can lead to those health and well-being outcomes that we all want to see. Ultimately, there's also a big opportunity tying this data into building management systems, building automation systems. We see a lot of really great examples here where you're able to automate this process to improve indoor air quality and also reduce potential waste when it comes to energy, because there's a lot of suboptimal HVAC usage in place around the world. So what are some of the main considerations when you're looking at how you're choosing a solution or a system to understand your air quality? Again, we'll not go into too much detail here. Very happy to talk to people offline if there's a desire to learn more. But really, I'd suggest starting with what are the goals of the project? Is it to improve indoor air quality? Is it to go after a specific building certification? Is it to sort of moving to like that statistic that I had earlier about millennials coming back to work? Is it to be transparent and share your air quality data to retain staff? So starting there, understanding what the goals are, the requirements, some of the limitations. And then there are that should inform the decision-making process. What are the requirements around automation, integration, so support for things like BACnet, MQTT, other solutions? Do you need data storage? Should there be a display on the device? And one that I would just briefly encourage everyone to really think about is maintenance requirements. This is a really important point. Make sure that whatever solution you have, it's easy to maintain over the long term, to keep calibrated, etc. Okay, so talk about the bottom line of clean air. So what is the ROI of not just monitoring? Because mostly so far I've been talking about collection of data. But again, the goal is not to collect data. The goal is to make positive improvements. So when we think about the benefits of IAQ monitoring, there's sort of really a few different pieces to this. There's generating value through having a cleaner, healthier space. There's some very clear cost reduction, and then there's maximizing of time. So if we look at those so one by one, generating value is I think, a really important piece here. So in just about every organization, talent is the largest overhead in business operations. That's talent is the expense for all businesses. And so it's never been more important for businesses to do really everything that they can to ensure the health and productivity and happiness of their employees. Improvements in indoor air quality can lead to really significant results, but are often overlooked. And one of the challenges is how hard it has been to see indoor air quality levels and to make a difference. So according to ASHRAE, poor indoor air quality costs us tens of billions of dollars every year in medical expenses and in lost productivity. The average person spends about 90% of their time indoors. I shared this before, and we spend 100% of our time breathing. So you can see the importance here. Poor air quality can lead to sick building syndrome, dizziness, fatigue, eye irritation. You can feel like you have a cold simply from exposure to poor indoor air quality. So there, I mentioned, I sort of quoted Dr. Joseph Allen at the start, who has really taken the lead in a lot of research around healthy buildings and around indoor air quality. And there are several studies out there, but just to share some of the key points, when it comes to VOCs, an increase of 500 micrograms per cubic meter in VOC concentration leads to a decrease in cognitive function by 13%. Increases in CO2 by about 400 ppm lead to also cognitive function decreases of around 21%. So these are major numbers. An increase in 400 ppm of CO2 is not uncommon. It's quite regular to see conference rooms that are well over 1,000 ppm because there are too many people inside, and that's an increase in 800 ppm roughly in CO2 levels. That's pretty common, and so you're looking at a decrease in cognitive performance of about 40%, which is very significant. And in that study, there was a comparison of days with fresher air versus days with essentially poorer air quality. And generally, cognitive scores on the days with fresher air, the green days, as they're referred to in the study, cognitive scores are about 61% higher on those days. So there's a major difference here. If you actually try to translate that into dollar value, and this is something that Joseph Allen looks at in his book, The 9 Foundations of a Healthy Building. The summary from that is that this change in performance is equivalent to around $6,500 per person per year. So an increase, essentially equivalent to an increase in salary of $6,500 per person per year from having good indoor air quality. And the cost of actually generating that from a ventilation perspective typically ends up being less than $40 per person per year. So that's extremely high ROI right there. Recruiting and retention, which is, of course, as we look at the biggest expense, which is talent, recruiting and retention is incredibly important, and it's been identified as the #1 problem for corporate America. So talent is becoming more selective when considering potential employers, and this is really an opportunity for organizations to separate themselves and to be able to stand out from the competition. This has led to, obviously, contributed to the growth of building certifications, LEED and WELL and RESET, and all of these healthy building certifications are something that companies can leverage to show that they are an employer that really cares about their staff. And this has been extremely successful. And indoor air quality is both a key part of that, but also another opportunity to really showcase how your organization cares about its people. In commercial real estate, there's, again, a lot of research, which I probably don't need to educate everybody on this call about the having the distinction of a prestigious building certification is definitely a way to increase the market value as well as market share when it comes to commercial real estate. So the WELL building certification, for example, is a certification that has a tangible impact on workspaces, often within the first year. And through the data that they've collected, WELL has found that building owners can attract and retain higher quality tenants and increase the overall financial performance and resale value. So this is all when it comes to generating value. Again, 400 ppm increase in CO2 is really not very much. I've seen conference rooms that ended up in the, they started in 400 ppm, and by the end of a meeting, they were in the 2,000 something ppm range, and everyone wanted to jump out the window. And if you do the math on this, you can see why. The second piece of this is really sort of around reducing costs. There is a major opportunity to reduce costs from an HVAC perspective. Many people will be familiar with demand control ventilation and how we have historically used CO2 to optimize ventilation rates. Well, there is a significant opportunity to do this not just with CO2, but with other parameters that we're measuring. Ventilation, HVAC accounts for typically 40% of total building energy consumption, which is a really, really high number, and leads to a significant carbon footprint. And so the opportunity to make improvements there is extremely significant. And we've seen buildings that could significantly reduce their HVAC consumption simply by being able to make more intelligent decisions based on a wider range of parameters. And finally, maximizing time. There's a lot that you can do by having, instead of receiving a multi-page report full of raw data that you have to sort of sift through and try to understand, there's a lot that you can do by having reports that are generated for you that actually have looked at the relationship between different monitors within a building and have understood what some of the root causes are for your problems, and then just give you summaries. So visualizing data sets side by side, these are things that maybe previously couldn't be compared. There are obvious questions that come up. So smart, intelligent reporting, which is really driven by having sort of technology that can provide continuous monitoring at all times, can give you things like weekly reports, detailed insights, comparisons week on week, comparisons month on month or year on year, tips for IAQ optimization, alerts if devices go offline and you're not collecting your data, and all these things. And ultimately, this can lead to a huge saving of time. Certainly, again, if you're going for any sort of building certification, I'm sure many people potentially on this call have had to go through the painful process of filling out complex documentation with all these different readings from different dates and trying to specify the accuracy of a monitor and then compare and see if it's can be used and if this lab report is applicable, et cetera, et cetera. A lot of this can be simplified and automated by exporting directly in the format that the building certification submission requires. So these are some examples of where you can generate some serious time saving. Okay, we're a couple minutes away from the end here. I'll go through these pretty quickly so that we have enough time for Q&A. But definitely wanted to share some case studies from some real world projects that we've found to be quite interesting. So this is an example from Microsoft. And this is a particularly interesting one. Microsoft is, of course, located in Seattle, where typically air quality is extremely good. For the vast majority of the year, the air is pristine. Unfortunately, like many areas, there can be a few weeks, maybe up to a couple months of the year, where the air quality can suddenly turn extremely poor, and it can be unpredictable and this is driven by wildfires. So you sort of have this potential source of terrible air quality in your backyard that might come at any moment, but also might not. And so what was done here is constant, continuous monitoring outside the building, as well as inside the building, and then those data points being used in real time to optimize filtration. So should dampers be open? Should dampers be closed? Okay, what is going to happen in how many minutes? When is smoke from the outdoors potentially going to have, be at risk of infiltrating our building, and we thus need to recirculate more indoor air? Then how do we balance the levels of CO2 that might be increased if we have higher degree of recirculated air versus the significant risk of essentially bringing in smoke from the outdoors? And this is something that you can't just set once and forget about and have a fixed solution for all 12 months of the year. Otherwise, you're going to be making some very poor decisions for a significant portion of the year. And so this is really an interesting example where it was possible to come up with a much better solution by having continuous values. And these are just some examples of how sort of what timely optimization tips and recommendations can look like, and how through smart reporting companies like Microsoft are able to make adjustments in real time, such as during wildfire season. Another case study from Puerto Rico. This was a significant project at this university where the goal was really to enable students and staff to return to in-person classes as soon as possible. And the goal is to make the return safe and to inspire trust and confidence. So the university committed to making a large investment in monitoring and improving air quality. SEG Engineering Group was chosen to lead the project, and based on the monitoring solutions that were in place, as well as a whole wide variety of different options for ventilation and purification and air cleaning, there was a really comprehensive solution that was built, and readings are available in real time, completely transparent, available for people throughout the university to view and then make more educated decisions about what technology should be used in different spaces based on the actual performance in that space. So in some areas, it might be that portable air purifiers were added. In some places, UV was added. In other places, ventilation rates were simply increased or decreased. So this is a great example of being able to dive sort of into the data and make more educated decisions. Not every classroom, not every building is designed or built equally or used in the same way. And finally, the Alliance Center. This is a co-working space, an event venue, an environmental nonprofit based out of Denver. And the challenge there was that COVID-19 really brought air quality to the forefront for a lot of tenants and occupants. So that was sort of one data point. That's something that people were really concerned about. At the same time, unfortunately, Colorado is also suffering from the climate crisis. There are wildfires, and they've become more prevalent, more common in the state. And increasing levels of particulate matter are a serious concern. So the Alliance Center is a nonprofit focused on health and sustainability. So there was a lot of internal research was carried out around collecting air quality data, sharing it, and really using that information to balance against air quality, energy consumption, and help the building make more effective decisions around upcoming changes to their mechanical ventilation systems that were planned. And of course, we try to make this, as straightforward as possible, so you can see very clearly this is what needs to change. If you change this, this is the increases in air quality that you would see. So sometimes the more data that you have, the more complicated it can be to interpret, and the more complex it seems to be. But really by assigning simple scores like this, where it's obvious what the areas for optimization are, the Alliance Center is able to make very straightforward decisions without needing to have a PhD in air quality to understand what the best option for them might be. Essentially the ROI and the pros and cons are calculated for them, so that it's very easy to know what decisions will sort of bring the biggest bang for buck. All right, so that brings us to the 45-minute mark, and just as we wrap this up and move to Q&A, just want to let everybody know that, well, first of all, a big thank you, for being here today, and hopefully this first portion was informative. And if you want to learn more, definitely, obviously, feel free to ask a question. We'll also be sending out this ebook, so you'll be able to learn a lot more about IAQ from this. With that, I think we'll move to the Q&A.
Thank you, Liam. That was fantastic. And you have a mountain of questions in the chat. So brace for impact. They're incoming. Everyone that's still on the line, you can still submit questions. Even if we don't get to answer them live, we will pass them along to Liam, and I think he would love to chat with you offline. So go ahead and submit those as it makes sense. There are quite a few questions asking about the recording of the session. So just a reminder for everyone, we did record the session. We will send you the link to it within 24 hours, and then you can find it posted on the Greenbuild website at any time as well. So hopefully that answers a few right off the top. Now, I'm going to start with a question from Melanie, and that is, how would you respond to a client who is concerned that monitoring IAQ could present risk for litigation, which would not exist when IAQ is not being measured?
Okay, that's a really interesting question. And I should preface this by saying that I'm not a lawyer. This is not my field of expertise. And so, take what I say sort of with a grain of salt and as coming from one specific angle. I think what we have seen, and this is something that we did hear more about in previous years. And I think the reality is that IAQ is something that has really come to the forefront of everybody's, like the mind of occupants. And the reality is that even if you're not measuring IAQ, there's a good chance that the occupants already are. You can go on Amazon, and this was not the case 10 years ago because you needed lab equipment, but you can go on Amazon, you can buy a pretty respectable indoor air quality monitor. A lot of people have them in their homes, and a lot of people do bring them to the office. And so I guess I would sort of flip that around and say, personally, I would much rather be in the situation where I know what is going on with my indoor air quality, and I know that I'm making steps in the right direction, maybe what some of the challenges are, and we're working to make improvements, rather than suddenly finding out that for the past N years, we've had a significant problem and nobody's been doing anything about it. And I'm only informed of it by somebody that's come in and taken a reading and then potentially started litigation. So yeah, I'm very much of the school that school of thought that the more knowledge you have, the better, because it helps you make more educated decisions, whatever those decisions might be.
Thank you very much, Liam. I think that's a great answer. There's a couple of questions in the chat related to continuous monitoring, and they're asking about how it's carried out. Are there specific devices? What equipment do you use to carry out continuous monitoring?
Sure. So just to answer that broadly, and so if we just jump back, actually, I think I can change slides and kind of go back to the beginning here. So this is an example of a continuous monitoring. This particular one has a display on it so that real-time readings are actually shown. There are, of course, options without displays. This particular device is designed and manufactured by us, but there are, of course, many, several companies out there that have devices for real-time monitoring. And what's essentially what you're looking at is a device that is typically wall mounted, sometimes ceiling mounted, but that's another topic of discussion, and is hardwired, sits on the wall and takes readings, and typically sends those readings to the building management system and or to the cloud so that they can be used for reporting in real time and sort of for aggregated reporting. And so hopefully that answered the question about what continuous monitoring typically looks like. Of course, you can check out our website. Just Google Kytera if you want to learn more about what specific products actually look like.
Perfect. Thank you. Okay, next question. Do you have any advice on delivering IAQ monitoring education to a building's facilities teams who manage the conditions on a daily basis?
Oh, that's a tricky one, because I think it can vary so much based on sort of the context and the actual situation. So we do a good amount of education work. I think what is really beneficial is, I think again, it's kind of part of the shift from more spot checks to continuous monitoring, and actually being able to have reports and summaries, is trying to make the data simple. The moment that you start talking about, here are the 7 different parameters, and this one is at 723 micrograms per cubic meter, we've already lost a significant portion of the potential audience. So whatever can be done to sort of just simplify the way that the data is communicated, and that's obviously what we try to do through weekly reports and sort of simple graphs like this that tell you red, green, yellow, the better. This is probably a topic that would take longer to really get into the weeds on, but happy to discuss it, offline afterwards if maybe more.
Okay. Sounds good. And again, Liam, we will pass all of these questions directly on to you. So if you want to follow up directly with any of the inquirers, you certainly can. Okay, so let's talk a little bit about the connection between IAQ monitoring and energy efficiency. Can you elaborate on that a bit?
Yeah, absolutely. So many people here would probably be familiar with demand control ventilation, which is simply, instead of having a fixed volume of air that's being pumped into a building or into a specific space, varying that amount of air based upon typically historically the CO2, like the real-time CO2 readings within that space. So if a room is not occupied, maybe don't keep pumping fresh air into it because there's nobody there. And again, HVAC accounts for typically around 40% of energy consumption in a building. So any optimizations that can be made there are really quite significant when it comes to the building. And so some examples of, so really what we're looking at is essentially expanding that to more parameters, because there are different things that can be learned and different ways in which the HVAC system can run based on those different parameters. So, for example, if there are high levels of PM 2.5, you probably want to pump more air in for that specific period of time, because you need to essentially flush out that contaminated air. But if the levels are low, then you don't need to necessarily continue ventilating at quite the same rate. And we've seen examples of, for example, a large tech company that we worked with, where we could see that for a pretty significant portion of time, the HVAC system was essentially over-ventilating the entire building. There were times when the building had nobody in it, and you could see that from the changes in CO2, the changes in VOCs, and simply by making optimizations based upon occupancy in different areas, which was derived from air quality, there were very large changes that can be made in the operating hours of the system and the different areas of the building and how they were serviced by served by the HVAC system. So that's the main area for optimization is finding where there's a disconnect between how much you should ventilate and how much you are ventilating, and then trying to align those better. You'll find savings there.
Great. Okay, can you elaborate on the steps that Microsoft takes with their HVAC equipment and controls when they determine that wildfire smoke ingression is possible?
Yeah, so in a nutshell, and so I should also preface this by saying that that was a couple of years ago, and I'm personally not sure exactly what system they sort of have up and running right now, if the logic has been optimized further, et cetera. But the basic premise simply that, well, there's two things. One is that when there is suddenly a high level of smoke outside, you do not want to be pulling that into the building. You want to be increasing the amount of the percentage of air that is being recirculated. Now, of course, that is going to lead to increases in CO2 levels. And if we were sort of coming at this from a more traditional perspective, just saying CO2 is the only thing that matters, then that could lead to some, honestly, some very poor decision making, which is let's keep ventilating the space and just bringing in smoke. But it's really about seeing that balance and saying, okay, we can deal with an increase of 200 ppm in CO2 if it means that we do not have smoke entering the building. That's a trade-off that is worth making. And so it's really about adjusting the dampers to optimize. The other thing is that when you have a sort of a campus the size of Microsoft, you can also start to understand a little bit better where smoke is coming from and actually forecast these events. So when this building right now might be okay, but in 2 hours or in an hour, there may be more more smoke at risk of entering the building, and so there's an opportunity there to actually bring in more fresh air before that occurs. So that's something that we were working on as well.
Thank you, Liam. Okay, this one I think is a good one. At what stage is it best to include these IAQ monitors in a project design? Is it ever too late to include continuous monitors in a new building design?
Oh, that's a great question. I mean, I would say the earlier the better, because the earlier that you do this, the more opportunity there is for deep integration with the building management system, the more flexibility you have when it comes to things like how where devices will be located, power. Are you going to be using power over Ethernet, et cetera, et cetera? So it's just going to become probably a more cost-effective solution, and you'll get more bang for buck the earlier you do it. But it's never too late. We do a lot of retrofit projects as well, and buildings have been operating for a long time, and there isn't full clarity on what the air quality is. And so monitors are installed, reports start being generated, and you can understand what's going on, and maybe some of the areas that we're not performing optimally can be identified and then fixed.
Great, thank you. Okay, there's a couple of different questions that have come in about how do you know when the device needs to be cleaned or replaced? Are there false positives for particulates? And then similarly, a few questions about calibration and how you know how good is your data if you're not fully calibrated, or how important is calibration? So I combined a few on you, Liam, in the interest of time.
That's an excellent question. Calibration is very important. Ultimately, we are trying to make data-driven decisions. That's the whole point of this, right? To be able to make smart choices based on data, and so we need to have confidence in that data. This is also one of the reasons why we stayed with spot checks for so long, is because the technology wasn't able to provide a really good solution. So calibration is incredibly important. And really happy that it's written into most of the building certifications. Devices must be annually recalibrated. There are different ways that this can be handled. The way that we do it at Kytera is that we design our products to have a modular design. So it's sort of like a printer cartridge where you can just swap out a sensor and in that way recalibrate your device, so you don't need to take it off a wall, send it across the country, have a specialist do anything. It doesn't cost a lot of money. So very straightforward and easy to use, but if devices are maintained and kept calibrated, then they do perform extremely well, provide very accurate data. But yes, it is important to maintain calibration, and I'm happy to say that I think that is extremely straightforward with the right solution in today's world. It's not what it was 10 years ago, where you needed to, essentially buy a new device.
Absolutely. Okay, well, we are just about at time, and there are quite a few additional questions, so we will pass those along to you in writing. Once again, I want to thank everyone for joining us today. This was an excellent and informative session. Especially thank you to Liam for taking the time out of your busy schedule to inform our audience on this important topic. Just a few quick reminders before we sign off. Today's session, again, was recorded, so you will get that link in 24 hours, and you'll also be able to access it on the Greenbuild website at any time. Before you do log off, we'd ask you to please take a moment to complete the feedback form so that we can continue to improve your webinar experience. And just a reminder, registration for Greenbuild in November in San Francisco is open. You can go to the Greenbuild website at any time and purchase a conference pass or join us on the expo floor. IAQ will be covered in several sessions in the conference there as well. And as a thank you for attending today's webinar, you can use the code WebinarThankYou when you register for an exclusive discount. On behalf of Kytera and Greenbuild, have a wonderful day, and thank you once again for joining us. Liam, thank you again.
Thank you, and hope to see everyone at Greenbuild.